In this session, we will discuss and demonstrate the innovations in the data engineering space in Snowflake Data Cloud. You have been following Snowflake. You know that we have a great portfolio of capabilities that already exist. We will talk about what's new. It's going to be a power pack 45 minutes. So let's get started. I'm Sat Mukherjee. I lead the product management function for our data engineering product area, and I'm joined by Parag Jain. Parag.
Hi, I'm Parag Jain. I work as a principal architect in Field CTO office in Snowflake.
Wonderful. And let's see what's in for all of us for the next 45 minutes. We will talk about the brief overview of data engineering in the Snowflake Data Cloud, why customers are choosing Snowflake as their preferred platform for bringing the most complex data engineering workloads. We shall look at the latest innovations, as I mentioned, and then we will make it real by stitching an end-to-end demo that takes advantage of all these new innovations. And Parag is going to take all of us through the demonstrations to make all these new functionalities come to life. Let's get started. Those of you who have been using Snowflake, you know Snowflake is the data cloud that offers a global unified platform for connecting companies and data providers with the most relevant data for their businesses. Wherever the data and the user live, Snowflake offers one single seamless experience across multiple public cloud. And what it does, that means you don't have to worry about public cloud specific implementation details. There are two specific elements of the data cloud, the content and the platform. The content is the most relevant and the valuable data that you need to analyze, right? And this could be data that you own as a part of your organization. This could be data that is coming from your constituents and collaborators, like a supplier and retailer sharing data, and data that is coming from the commercial data providers. We have hundreds of commercial data providers who are offering data and content in the data cloud. And the platform, the Snowflake platform, offers a unique architecture that allows you to get access to the capability to ingest, process, analyze data without having to worry about the underneath infrastructural complexity. And in the data engineering specific workloads, we will focus more around the Snowflake platform capabilities today. So let's get moving. So why customers are choosing Snowflake as their preferred platform for data engineering? There are many reasons. Let's talk about the most important reasons here. First, today, enterprises are accessing a vast amount of data coming from different sources, all types of data, structured, semi-structured, unstructured data. And many of you are data engineers, you know that data is not just batch-oriented anymore. Data is coming from streaming data sources. So all sorts of data. Snowflake offers a single platform that allows you to access all these different data types, structured, semi-structured, or unstructured, batch or streaming, using one single homogeneous platform. The second most important piece is performance and reliability. Now, those of us who have been in the data engineering space for a long time, we understand it's one thing to build the pipeline, and it's the other thing to make sure that the pipeline is reliable. I'm sure Parag is going to talk in his demo how important it is to make sure that the data just gets delivered every single time without you have to right size the pipeline depending on the workload that you are running. So Snowflake offers an elastic performance engine that lets you kind of scale up or scale down pipeline depending on your work needs. It's fast, it's reliable, it's scalable, and Snowflake also offers a great way for you to manage your pipeline workloads through the virtual warehouses. So instead of you worrying about concurrency limits and access control to a production pipeline, you can basically delegate different pipelines to take advantage of different virtual warehouses, and multiple workloads can simultaneously run in the platform without you worrying about performance. And the last and not the least is about the complexity of running pipeline. Like as the data volume grows and the downstream usage increases, at times the pipeline gets fairly complex fairly soon. Now with Snowflake, with data sharing, what happens is you have one single copy of data that exists in the platform. Now that same copy can be accessed by different data engineering team to perform different type of processing tasks and for different types of downstream consumption patterns, like somebody is using that data for BI reporting. Your data scientists want to do feature engineering and basically train models on that data. With Snowflake, there is no infra and no ops, right? So once you develop a pipeline, you are not managing the pipeline related infrastructure. And it's one single platform for any language that you as a data engineer love to use. And we will spend a lot of time talking about Snowpark, the latest innovation from Snowflake around building extensible data pipelines in the language that you already like, using Java, Python, Scala. And we will spend some time going through the demonstration of how Snowpark works and give you this flexibility. So again, to wrap it up, all data that you want to analyze and process without worrying about the scale up, scale down, infrastructural complexity, and the language that you love, all of that is making Snowflake so appealing as a platform for data engineering. So now that's what we tell. What's our customers are telling? So some of these are fairly known and popular brands, right? Western Union is a leader in financial services. They help mobilize money, send money, and pay bills for many of us. And when they move to the Snowflake Data Cloud and they move their data warehouse, they experience 85% reduction in their overall cost of running the data pipeline in Snowflake. Now, Western Union also reported that they saved millions of dollars in running data engineering pipelines in Snowflake compared to the previous systems that they had. And it also helped them to improve agility in their data science teams by moving data into Snowflake, pushing data in and moving data out for machine learning purposes. Rakuten is a leading loyalty program provider in the United States, and they run into the resource constraint for data pipelines in their previous legacy platform that they have. They had fairly complex architecture to get access to multiple data sources, stitching the data, mashing that data up for downstream users. And they had fairly complex ETL processes. With moving to Snowflake, now they run almost 10,000 plus jobs with 99.5% success rate. So it just works. Moving the data pipelines to Snowflake helped them achieve almost 95% faster runtime for the same use cases compared to the previous version of the pipeline that they had. Uniper generates, trades energy across Europe and North America. What they experienced is almost 10 times performance improvement at 30% lower cost of running data pipelines in Snowflake compared to the previous platform that they had. And these helped them to make this data available to a larger number of users within Uniper, right? So it basically helped them to democratize access to the data without worrying about performance and infrastructural bottlenecks. So all these innovations help us to get motivated and even innovate faster. So let's talk about what's some of the basic building blocks of data engineering in Snowflake. Those of us who are new in Snowflake, you will find this informative. Those of us who have been operating in Snowflake, we will talk and highlight some of the newer pieces here. So on the data ingestion side, we allow you to ingest data, all types of data, using a variety of options and services like copy, SNOWPIPE, Kafka connector, lets you move data from batch as well as from streaming sources. Once the data lands in Snowflake, then you can perform transformation using ANSYS SQL. Those of us who are more comfortable using Java, Scala, or Python, we will talk about Snowpark, how it's making easier for you to perform the same transformations in Snowflake without worrying about the language. And then once you have transformed that data, you have created the right views, you have done the right type of data cleansing, you can deliver the data seamlessly in Snowflake for downstream users like the BI users or the data science users. And Parag is going to show in our pipeline, when you clean the data, how easy it is for you to deliver the data for downstream usage using data sharing as an example, without further copying the data. And then we offer a variety of drivers for you to take the data from Snowflake into data lakes or other systems for activations on those insights. So as we continue to innovate, we are going to focus on what's new since the June 2021 summit. So there are 6 things that we are going to focus today. The first being the ingestion performance. Now with SNOWPIPE, we announced the ingestion performance improvements from June. We will talk what we are experiencing with those improvements in place, how it affects latency for you in your pipeline. The second one is schema detection. Now schema detection makes data pipeline development faster and much easier with automated detection of schema and without you writing DDLs again. The third one is support for unstructured data, how seamless it is for you to now ingest unstructured data into the pipeline. Now, and as you develop pipelines and ingest data, we are bringing in visibility, better visibility in these pipelines through ingestion dashboards. So you can go to Snowsite, you can understand how the data was loaded, which files failed, which file worked. So you will have much better confidence in your pipeline. And then we will spend some time on the latest innovations with Snowpark. We'll go deep into this area. And then the serverless task, those of you who have been following, we announced the public preview of serverless task, a new capability that brings much more efficiency in already popular tasks for running jobs in Snowflake. Now, having said all of this, instead of keeping this all new capabilities abstract, we will ground them into one end-to-end demonstration. Now, in this demo scenario, it's a telecom company, and their data science team has been tasked to predict churn of potential customers by looking at data that exists in their platform. Now, the data science team can only start their work when the data engineers make their data available to the data science team. And no one knows better than Parag, because you have been working, Parag, with larger customers who are working, the data science team is working with data engineering team on a day-to-day basis.
So as a data engineer, right, we want to build an end-to-end pipeline with Snowflake and reduce the overall cost and technology footprint so that there are less point of failures. On one hand, as you can see on the left-hand side, we have customer billing data and demographic data saved in semi-structured format in Parquet specifically. And on the other hand, we have customer emails and requests that's coming to our support tickets in any unstructured format like a MIME or EML file. We want to simplify the data pipeline by ingesting and processing the data closer to Snowflake. But there are multiple developers, persona in our team. There are some SQL developers, some Java developers, and some Python developers. So we want to utilize the whole team as well. We also need to make sure that at the end of the pipeline, we provide clean, transformed, formatted, and create a feature store for our data science users to perform churn analysis and sentiment analysis. So traditionally, if you want to do this, the architecture could look like something like this, where you have everything boxed together in separate virtual machines or separate tools. So our goal is to provide quality insight with the data in hand. So a traditional Spark-like technology will make too many data hubs and processes while loading this data. And each of these arrows that you see in this diagram will be a separate data pipeline and will be a separate engineering task itself. Now, it will need to be processed separately in terms of number of clusters, data lake storage, or data warehouse, user accounts, and end-to-end point need to be secured. So every arrow will itself require some kind of engineering. Now, this will create many points of failure. You will need to hire and retain highly skilled and talent pool, and this can all become a bottleneck further later in the pipeline. So let me show you how Snowflake can solve this problem. So we can make this all much simpler and run this entire pipeline within Snowflake. A singular platform will help us provide more governance and control over the data, and it will also help make our developers' life easy. Developers of different skill set can set their bars and can collaborate, and we can streamline the whole architecture, all within the same speed of cloud and elasticity. With this will make all the data processing much more faster, and then you can market your product and project much more faster. So let's look at the reference architecture and how it can all come together. So we are going to break this down into 6 easy steps. Start from ingestion to consumption and processing and doing all this through an automated process in step 6. So Sep, can you tell us more about the step 1 and 2 about the data ingestion and schema detection?
Absolutely. So the number one feature that we are going to talk about is faster auto ingestion with SNOWPIPE, right? And we talked about SNOWPIPE performance improvements in our June summit. Now, those of us who are new to SNOWPIPE provides ingestion service on Snowflake for you to bring data into Snowflake with automatic ingest and a REST API-based support. Now, SNOWPIPE is serverless, and it manages all the load capacity and optimized compute behind the scenes so that you don't have to worry about, again, infrastructure management. It's highly popular with our data engineers who are working on Snowflake. Now, in June summit, we announced that SNOWPIPE is going to have latency improvements, and I'm pleased to let you know that we have completed that engineering work, and now the users of SNOWPIPE are experiencing 50 to 60% median latency improvement across all the cloud deployments. So the same pipelines on SNOWPIPE is running faster. The second capability, staying in the tune of making pipelines faster and more efficient, is schema detection. So schema detection allows now developers to understand schema from underneath files like Parquet, Avro, ORC without manually trying to detect the file structure and writing DDLs manually to create new tables. It allows you to automate the whole process of detecting schema and creating tables in Snowflake and dramatically reduce the overall time that it requires for you to develop new pipelines. We are also working on schema evolution that will make schema detection and evolution both possible right out of the box in Snowflake. So stay tuned for the availability of the Snowflake schema evolution capabilities sometime soon. Now, let's see this in action, Parag, like how you're going to use SNOWPIPE and schema detection in the demo pipeline for faster and much more efficient pipeline development.
Absolutely, Sep. And so we are in the first stage of our data pipeline cycle. And in this stage, we're going to ingest the data which is provided to us in the S3 bucket in terms of Parquet file. And we are also going to see how we can read through that file and create tables out of that using schema detection features. So here we have our data saved in S3 bucket. And in simple, easy step, we can integrate this with Snowflake using object called as external stage. Once we create the integration object and external stage, we can list out the files sitting in the S3 bucket. And these are the files that are provided to us. They are in Parquet format. Then we can go ahead and create, use one of these files and create a table, raw table, using new schema detection feature. Once we create the raw Parquet table, which is using the Parquet file that we just got, we can start our pipe. In order to start the pipe needs to know where the file is sitting. And we can use the column match function to use the schema which is already present in the file and then load that into a Parquet table that we just created. Now let's see if the files are processed. As we see, within seconds, all of the files that are present in the S3 bucket are now processed. Let's see if we have data in our raw Parquet table. So we have close to 100,000 records now in our Parquet table. Let's see if all the files are processed and we have collected the necessary metadata from the files. So as you can see, the raw Parquet tables are now processed, and each file has some 7,000 or 8,000 rows, and they are all processed without any error. So back to you, Sep. Tell us more about the new features that are available that we can integrate in our data pipeline.
Thanks, Parag. So this brought the schema detection to life, and we saw how easy it is for you to create table without writing TDLs directly from the Parquet. But we didn't stop with just the structured or semi-structured data. Now we have support for unstructured data in public preview in Snowflake. So that means you can now start ingesting files that are unstructured directly into Snowflake for data processing needs. And we will show how, in the context of this demo, Parag is going to use unstructured EML files and process that file for feature extractions. Now, with unstructured data support in Snowflake, now we also offer directory table for built-in file catalog. Parag, let's see this in action, the support for unstructured data.
So in the next step of the pipeline, we have some unstructured data coming in EML format. This is a MIME format, which is unstructured. So in order to process this, we have to use some kind of parsing engine. Now, before we even do that, we have to add this data to our data repository. And in order to do that, we use something called as external stage again. These external stage will now be supporting unstructured data, and will also support directory tables. Now, when we create these unstructured data buckets in Snowflake, you can put the files that are available to us, or it can be sent through a pipe. Once the files are uploaded, you can see that these are EML format and they are not actually directly consumable. So what we do is, in the next step, we create another external directory where we host the processing jar files or the processing Java code that will process these files. In order to do that, I have simple Java code which will parse these EML file and extract subject, body, and other email information from this file. And I have created a jar file for this, and I've put those jar files inside an internal stage within Snowflake. Now, as soon as the jar files are available, I can actually write a simple function to call that jar, to call the function in the jar file, and then use that function to process the email information. Now, once I start parsing the emails, it takes within seconds to parse the whole email, and then I can actually load that into a table. And for this, I'm going to use a customer table, a customer email table, where I will save the email from information, subject, body, and the date that I've received. And I can do this by simple table function called get, to get the email part from the processing, and then the subject, body, and the retention date. Once I process this information, I can do this for each email, or I can create a procedure to run this for all the emails that I've received in the day. Once I do that, I can see that the email information is now saved, and the body of this email can be used to process the sentiment of the customer, whether they are trying to get rid of the service, or whether they are saying something good about the services that we are providing. So in this way, our data science team get a clear, clean data without actually investing time in processing this information out somewhere else. So Sap, tell us more about the next exciting things that we can use in our pipeline.
Thanks, Parag. That was really exciting. You could ingest unstructured data, process it all within Snowflake. Now, as the pipeline gets bigger and more complex, as data engineers, we need visibility and insights from the ingestion pipeline, like what's happening. Pleased to let you know that Snowsight now provides ingestion history, copy history, and other useful information in a dashboard for SNOWPIPE. This includes copy commands, SNOWPIPE, and Kafka Connect that loads data into your tables. You can see the last 14 days of copies and filter down to specific statuses. In private preview, this capability will come into public preview sometime soon. Now, in our demo scenario for this churn analytics, Parag, how does this visibility into the ingestion dashboard help you?
Sure, Sap. So if you look at the database, if you go to the new UI, first of all, you have to be on the Snow site. So if you go to the new UI and click on data and databases, and then look at the table that you just loaded, you will have something called as copy history for that table. What this does is it shows you the history of, like you said, last 14 days of data that is loaded in that particular table. So we have just loaded data a few minutes ago for the telco churn, and it is using the data file that has been uploaded in the S3 bucket. So it gives us a quick, complete view of what's going on with your pipeline and whether that data is loaded or are there any errors in the pipeline. So it provides a very quick analysis and quick monitoring tool for everybody, for all the data engineers and data architects that are monitoring the data pipeline.
That's great. I mean, this makes it so much easier for you to debug the pipeline too.
Yeah, absolutely. Yeah.
Let's talk about transformation and let's talk about Snowpark. So those of you who have followed Parag's demo, you have seen Parag is using a Java UDF in his demo to access the unstructured data. Now, Java UDF is part of Snowpark, which became publicly available in June. Those of us who are new to Snowpark, Snowpark is a new developer framework for Snowflake. It allows data engineers and data scientists and developers in general to code in their familiar language of choice and execute pipelines, ML workflows, and build apps faster, more securely in one single platform in Snowflake. It brings deeply integrated data frame style programming to the languages developer already like, and the functions to help you expand the use cases of usage of data on Snowflake. Snowpark supports Scala APIs, Java UDF, external functions, and we will talk about how we are expanding the support of Snowpark to Java and Python. Snowpark truly opens up your ability to program and play with data in Snowflake. So why developers are talking about Snowpark, what's unique about Snowpark? Now, those of you who have been following the data engineering space, data engineering is no longer just confined to SQL, right? You are using languages like Python or Java or Scala to manage pipeline. Data scientists, Python and Java are fairly popular programming languages of your choice. As Parag mentioned earlier, now there are a lot of complexities with different teams trying to use different languages. They have to set up their own cluster, their infrastructure to work with data. Now, what Snowpark does is let all teams to come and collaborate on the same copy of data in a single platform, instead of worrying about managing different infrastructure and runtime just because you are programming in different languages. So it lets you operate on a single copy of data in a single platform. The second thing it does, it allows the access of data in Snowflake Data Cloud to users beyond the SQL users and lets you build workflows and pipelines and apps at scale, right? Because Snowpark is running natively inside Snowflake. That means you don't have to worry about performance and scalability because it's optimized to run in a highly scalable multi-cloud environment. And the last but not the least, Snowpark lets you take advantage of the same security and governance control that Snowflake offers, right? Snowpark is secure by default. So you as an account admin have complete control over the libraries that you will allow the developers to execute within Snowflake. The runtime of Snowflake compute clusters do not have access to the network. That means you can avoid problem like network access from the apps without permission. Again, all of this, you can run Snowpark and the different apps built on top of Snowpark in a well-governed, secure environment consistently without you worrying about security and governance pitfalls that will come with developers spinning up their own infrastructure and accessing data that are valuable to your enterprise. So it brings the enterprise-grade governance and security capabilities in Snowpark. Now let's see Snowpark in action, Parag.
So far in our pipeline, we have ingested the data using SNOWPIPE. We have created a data schema without actually writing some schematic code. We just detected and built a raw table. So now we have raw data sitting in our database, and we want to make sense of that data. We want to create some kind of model out of that data. So I'm going to create a star schema using Snowpark for that. And for that, I'm going to divide the raw Parquet table data into demographics, location, services, and status. I'm going to use Jupyter Labs as a notebook environment for my Snowpark. You can use any development tool, any IDE. We will start by writing some boilerplate code to include the libraries required for Snowpark. And once we include the libraries required for Snowpark, we can start writing a data frame type code to process this raw Parquet table into demographics, locations, the services that these customers are using, and the status of their service. Once we run this data frame style code, we can also on the fly transform this data. If there are any null values, and if there are any checks and bounds that we have to do on the data, we can all include that in our transformations on the fly while we are converting or extracting that data from raw format. Once we do that and our schemas are ready, we can actually run this code in, again, data frame like format and join this together to extract meaningful information out of this data. Like I'm doing here, I'm trying to find out by all city, what's the total charges and what's the total revenue that I have made for all the accounts, and what's the contract detail of that particular account, whether it is a month-to-month contract or a 2-year contract. So I can do that easily within Snowpark, within the language of your choice.
Thank you, Parag. Now, we talked about Snowpark and the support for Java, but Snowpark is more than that. And those of you who have been into our keynote earlier today, we talked about the availability of Python support in private preview in Snowpark. So what it does for you as data engineers and data scientists, it lets you collaborate with other data teams using Python's familiar syntax and the strong open source libraries that exist in Python. You can access the most popular open source Python libraries without manual installs and package dependency management. Now, this is going to dramatically reduce this whole infrastructure management and dependency management and help you accelerate build pipelines. So you can build with confidence, right? Now, we talked about how Snowpark takes advantage of the security characteristics and attributes of Snowflake directly. So you can build pipelines with Python and Snowpark and essentially remove any roadblock that might prevent you from going from development to production in a secure Snowflake engine, right? And we run Anaconda verified open source packages to help you accelerate that part. Now, for the Snowpark live demo in action, I would encourage you to attend our data science session where we are going to have a detailed demo and we will go into the details of how to run Python jobs in Snowpark. Python support is in private preview. I will encourage you to sign up today to stay in the loop. So till now, we talked about building the pipeline. Now, tasks, those of us who are new again to Snowflake, is a user-defined way of running and executing SQL statements on a periodic basis, right? You can run a task on a given schedule by configuring it. You can use a combination of intervals, or you can essentially create flexible schedule by using a subset of familiar cron utility syntax, right? So those of you who have been using task, we announced the public preview of serverless task. It's the same task, but it's much more efficient. So instead of you assigning a warehouse before you write the task, serverless task basically allows users to create a task without worrying about the compute load that is required to execute the task efficiently. So Snowflake looks at the historical usage pattern for that task and assigns the right size of the warehouse with that task. So the same pipeline for different transformation, different workload requirements will now scale up and down automatically in a true serverless manner, right? And customers and our partners who are building applications like multi-tenant apps and SaaS apps will greatly benefit from something like serverless tasks. Now, Parag, in our demo scenario, like as this pipeline, when you are analyzing churn data, the data volume is not consistent. So your pipeline needs to scale up and down depending on the amount of data that is thrown at it. So how do you take advantage of the serverless task in this scenario?
Sure, Seb. It is a data engineer's dream, to build cost-effective processes. And in order to do so, something like serverless task will be a great add. And let me show you how we can incorporate this in our pipeline. So what we have here is I've created a serverless task. And in order to create that serverless task, you just need to define an initial warehouse size, and it will scale out automatically using that size if it needs more. So what we are trying to do here is starting with an extra small size, and we are also trying to add an incremental feature store. So what I've created is a table which hosts all the features of our churn table, and this is the feature store which will be utilized by the data science team for churn analysis. So I want to make sure that I put useful information, clean information in this table. And for that, I'm using a procedure called as ordinal encoding in SQL. This is a simple encoding process which encodes the features in numerical format. I have started with a 1-minute task, and I've resumed the task already. So let's see if the task is completed. All right, seems like the task is completed. Let's see if the data in the feature store is now up to date. Now, there are many things possible with serverless tasks. This is just an example to provide clean data to our data science team on time. And you can see that the ordinal encoding for a text support column is now done. We have all the numerical values there. So what else we can do? Now, once this feature store is ready, we can actually share this data with our data science team by a few clicks of a button. So you can go and start sharing the data that we just created. Go to the table. I want to share the feature data with my data science team. I'll just call it out, feature data, and then I can just call my account that I want to be associated with, and then just create the share. As soon as you create the share, they will get this data, and then they can start consuming that data. And in future, if you want to add more consumers to it, you can just add that by clicking Add Consumer button. So it's that easy.
Yeah, I mean, this makes the last mile delivery radically simple. Like we talked about the delivery of the data, like you process the data, but somebody has to use it downstream. But now with data sharing, it's always live, always fresh. So the data scientist is not going to ping the data engineering team like, hey, has the data been delivered? So I'll pick it up. And then it's always live, and it promotes collaboration between the data engineering and the data science team in a great way.
That's the whole magic of data cloud.
Yeah, that makes it real. So thanks, Parag. So I think it helped us, the whole demo helped us to make these innovations come to life, right? In this demo, we saw how Snowflake Data Cloud is making it radically simple for data engineers to build reliable data pipelines, carry out transformations in the language of your choice with Snowpark, and deliver the data seamlessly using data sharing with one unified experience. Now, let's recap. We discussed SNOWPIPE's latency improvement, and now it's available across all deployments. You don't have to turn any knobs. You can experience the latency improvement in SNOWPIPE. We showed you schema detection, and our investments in schema evolution will help you to accelerate pipeline creation and maintenance. The support for unstructured data management includes built-in capability to store, access, process, manage, and govern unstructured data in Snowflake. Ingestion dashboard with SnowSight now offers greater visibility into your data pipeline. And with Snowpark support for Python, Scala, and Java, you have the maximum flexibility as developers to build the pipeline in the language you already love, taking advantage of the same scalable, governed infrastructure that Snowflake offers. And then serverless tasks makes your pipeline much more efficient and easy to manage. So those of you who are, again, interested in Snowpark Python session and unstructured data analysis details, I would encourage you to go ahead and attend this What's New for Snowflake for Data Science and What's New in our Data Lake and Beyond session. From Parag and I, thank you for joining us today. We can't wait to see what you develop as your next data engineering solutions in the Snowflake Data Cloud. Thank you for joining us.
Thanks again, guys.